Okay, this problem begins by saying that in a given suburb, 55% of the houses have garages, 40% have decks, 30% have both. So if it's telling me I have one event, a second event, and then both, this is a Venn diagram. So let's create ourselves a Venn, which we want to make a rectangle. And then within said rectangle, we would like to make two circles. One of those circles represents having a deck, and the other circle represents having a garage. I'm going to go ahead and use whole numbers and make this a little bit easier on us and assume there are 100 homes. That way, if we think about 30% of the homes, that's exactly 30 homes. So we can use whole numbers. Let me just make this like a little bit thinner, perhaps. Can I do that? Okay. All right. So we've got 30% of the houses that have both. We're going to start there, and we're going to put that 30 smack in the middle where both of the circles interlock. Then we can move to the other numbers. It says that 55% of the houses have a garage. I'm not sure why I put deck first if they mentioned garage first. So I'm going to go over to the garage circle, which I, for some reason, put on the right. So I'm going to take 55 and subtract the 30 I already put in the middle, which leaves me with a final result of 25. Then I'm going to go over to the left-hand side, and I'm going to do the same exact thing. I'm going to take the 40% that have the deck, and I'm going to subtract the 30% that have both, which will leave me with the houses that have only a deck. Then what we're going to do is we're going to move outside, and we're going to find this missing number that should be outside the circles. If we're assuming there are 100 homes, then we're going to subtract all of the homes we've already included. The 10 with only a deck, the 30 with both, and the 25 that have only a garage. So together, that is 65 houses, which leaves 35 houses sitting outside of these two circles. That's 35 houses that have no deck and they have no garage. Okay, so now we're going to use that image to answer the follow-up questions together. The first question says, what is the probability a randomly selected house has a garage or a deck? For some reason, I really want them to mention the deck first. I have no idea why. Okay, so the word or in probability means to add. So this would look like the probability they have a, let's actually do it the way they said, so I apologize. They have a garage or a deck. We want to add all of the hard work that we've done. So there's actually two ways to do this problem. I'm going to do this the way I think is the easiest, the first way. And I'm actually going to stick everything over 100 because there are 100 total houses. And a garage or a deck in our probability world means one or the other or both. So that would be the one deck only or the other that's garage only or both. So I'm actually going to add all three of those numbers that we've put in the middle, which makes this 65 over 100, which does simplify to 0.65. My other option, however, and I'm going to go ahead and do that up here in a different color, is that I could use the addition rule. I, again, think this is the more difficult option, but I could think of this like our addition rule, which says that would be the probability they have a garage plus the probability they have a deck minus the probability they have a garage and a deck. So that would actually look, and again, I'm going to put everything over 100 to make my life a little bit simpler in terms of the way it looks. That would be going back up to the original problem. How many have garages? 55% have a garage. How many in the original statement have a deck? That's 40. How many have both? 30. So if we do that math, no matter what way we do that work, we arrive at the same final answer, 65 over 100, or 0.65 for our final answer. Okay, let's keep moving. What is the probability a randomly selected house will have neither a garage nor a deck? So neither nor, this is talking about being outside the circles. This means that neither of the events is true. So they have no garage and no deck. And that's the number outside of both of the circles in our Venn diagram. So for us, that's 35 over 100, or if you're using decimals or we're converting everything back, we want to make that a 0.35. All right, only 2 more left. What's the probability a randomly selected house will have a deck but no garage? Ooh, this is just a fancy way. If they say not a garage, this really means that they have a deck only. So it's no overlap with the G circle. We can only choose the number that's sitting in the deck circle. It could not possibly be in the overlap as well. So this is only the deck. There are still 100 homes to choose from, and if you look up at the picture that we created, only the deck would actually be looking at the 10 values that are sitting in that left-hand circle. So this is 0.1 or 0.10. All right, one more question, and then they're asking us about independence in the end. So D says, what's the probability a randomly selected house will have a deck if it is known the house has a garage? Okay, so this is like some fancy language here. If it is known is just another way to say the word given. So this is really saying it has a deck given it has a garage. So why don't we use our formula? We know that deck given garage would look like that if we're using the proper notation. And that means that the numerator would be houses that have a deck and garage, and the denominator would be houses that have a garage. So in the numerator, we put the number in the middle. I love this. That's the 30 that sits in the middle because it's both at the same time. But in the denominator, we actually have to think of everybody in the garage circle. So I actually revert back to adding. And I say that that's actually 30 plus 25, which makes this 30 over the original 55. And if you put that into your calculator, you would get 0.5, wow, 0.5454 repeating. Okay, so I'm going to leave it at 3 decimal places. All right, final question. Are the events having a garage and having a house with a deck independent? Justify using probability formulas. Okay, so let's write this in a different color just to make sure it's clear. Let's use just like A and B. A and B are independent if the probability of B given A is equivalent to the probability of B. So what this statement is saying in words is that the conditional statement, or A, if B given A is equal to the probability of B, then it doesn't actually matter that A occurred first or is the condition. It has no impact on the probability. So we need to check if this is true. Are these two probabilities the same? And I'm going to use the probabilities from above. So on the left-hand side, I'm going to replace with deck given garage. So now event B is having a deck and event A is having a garage, which means I'm going to put like a question mark to test if this is equal. Is it the same to say that someone has a deck given they have a garage? Is that identical to the probability that they just have a deck on their house? So let's test this idea. I'm going to go ahead over here. The left side, though, let's label underneath. The left side of this is actually part D. We already did that. And the right side of this we can find from the Venn itself, right? We can figure out how many houses in this entire picture have a deck. So on the left-hand side, let's put part D. That is 30 over 55. And we want to know, is this equal to all the houses that have a deck? So first, let's start with all the houses, 100 houses in the neighborhood. And the ones that have a deck are the 40 houses in the deck circle, all the houses that have a deck. So on the left-hand side, we get 0.545, just like part D. And on the right-hand side, we get 0.4, if you simplify that. And these are not equal. So therefore, the variables are, I just said not variables, not independent. Did I spell that right? Whew. Girls, no. Not independent. Okay, finally finished. Keep up the hard work. Can't wait to see what you do for your review video.